Hello, friends. In this lecture, we will focus on Tollen's reagent, organic chemistry. Normally, in textbooks or notes, aldehydes react with Tollen's reagent. The reaction is shown directly in this fashion. Yes, I will write. It is two. This is directly written in this fashion, and therefore, students feel that it is difficult. Actually, what is the chemistry behind it? Redox point of view, functional group point of view. If we go through that, if we apply our mind on the fundamentals, then it will not become necessary for us to by heart. That is not the way to learn chemistry. And even our multiple choice question type exams, JE, NEET, this helps. Now, this ethanol with this Tollen's reagent gives carboxylic acid and silver, elemental silver. This is what the reaction is. Actually, this is further neutralized. I am not showing here. Neutralized with OH minus ions. That is the extension. Core chemistry, core organic chemistry. We have to focus. Therefore, I have not shown that additional step, neutralization, because this is basic, and this gets neutralized to give salt corresponding. What one should know so that the study of this reaction becomes easy. First thing is that aldehydes on oxidation gives carboxylic acid. Means aldehyde group, when it gets oxidized, gives corresponding same number of, depending on the aldehyde we have taken, carboxylic acid. So this is oxidation. So aldehyde of 2 carbon atoms will give corresponding acid of 2 carbon atoms, ethanoic acid, acetic acid. That is one thing. So the moment you write aldehyde plus Tollen's, this gets aldehyde minus the product is fixed. And now let us find the oxidation number of the functional group carbon. Carbon and the bond is with same element carbon. The charge on this carbon because of this carbon will be 0. Carbon is more electronegative than hydrogen. Hydrogen will carry +1. So since it is a covalent bond, if it were ionized, separated, the concept of oxidation number, the charge on carbon will be, because of hydrogen, it will be -1. And since oxygen is -2, because of that it will be +2. Okay. So because of oxygen, it should have +2. Because of hydrogen, it should have -1. So in all, in totality, it becomes +1. So +1 oxidation state changes to, we can find here, because of this oxygen, the charge on this carbon is expected to be +2, because oxygen is -2. The covalent bond is between two same atoms, therefore charge on this carbon because of this carbon will be 0. Now hydrogen +1 and oxygen -2. So whatever is charged because of this, -1 is balanced here, and therefore here it will be -2, since balanced here, +1. So total, if you make the total +1 because of this group, -2 +2 because of this oxygen. So it becomes +3 total. Total becomes +3. So when aldehyde changes to carboxylic acid, when aldehyde group changes to carboxylic acid, oxidation, it can be any aldehyde, therefore I have written in this manner, carboxylic acid, plus 1 oxidation state of carbon changes to +3, +3. So each molecule, means it should be considered as mole. So 1 mole of aldehyde will require 2 moles of electrons. 2 moles of electrons. And silver, although it is written in this fashion, Tollen's reagent, actually it is this silver nitrate added to water in presence of ammonia. Now it is expected that with water, silver nitrate will get converted into AgOH, which is a sparingly soluble, will give precipitate. So, but in presence of ammonia, we can avoid this. That is why ammonical silver nitrate solution, we take it as. And what we get is, silver forms coordinate covalent bond with 2 ammonia molecules, neutral ligand, neutral ligand. And in aqueous solution, the ions are free. Although molecule we use in this fashion, the molecules, the ions, this is complex ion, this one is again ion free OH minus ions basic solution. So it can be written, it is more convenient to write in this fashion. The same thing, if you write in this fashion, it is convenient. Or I can repeat it here. Ammonical means silver nitrate solution added to water in presence of ammonia. So in presence of water, it should have been, we expect that it should be this, but this is finally soluble. The silver will be not available. Silver in the form of +1, Ag+1 will not available for reaction easily. So that was there in our minds. So ammonical, when we do it ammonical, ammonia molecules, Ag plus ion has capacity to form 2 coordinate covalent bonds. And in this form, +1 charge will remain +1. These 2 ions in aqueous solution will be free. So Ag plus will be available free for the reaction with aldehyde. And OH minus also separately available in free form. So this should be in our minds. And therefore, if one aldehyde molecule changes to carboxylic acid, 2 mole of electrons are available. Therefore, Ag+1 which changes to Ag, such 2 should be available, and 2 Ag, 2 should be available, isn't it? Let me write it again here. This +1 and OH minus ion. So Ag+1 changes to Ag, such 2 are available. So if these ions are 2, automatically this becomes 2, because both the ions come from the same molecule. Same molecule. So this gets precipitated. So automatically 1 molecule of aldehyde gives carboxylic acid. Correspondingly, it will reduce 2 moles of Ag plus 2 Ag. So here it will be 2. Means if I write in this fashion, it becomes 2 and 2. And when Ag+1 changes to 0, ammonia get released. The ammonia released 2 moles per complex, 4 moles of ammonia, and remaining water. So the aim of this lecture is not to teach whatever you get from notes, textbook or routine lectures, expecting that you have done that. But this chemistry should be added in that, should be included. It should be studied in this fashion by considering aldehyde functional group, when it oxidizes gives what is the change in oxidation number. So then how much Ag plus will reduce. If all these things separately studied and if collectively applied here, then it is not necessary to memorize blindly chemical reactions, and actually it is not a way to learn chemistry. This is the proper. So these much things, if they are known, oxidation, redox, balancing of electrons. Then the reaction, even though if it is directly written or if we wish to write it directly, it becomes easy. So let me repeat it. So we should learn in this fashion. We can write in this short form. Aldehydic function group with Tollen's reagent get oxidized to carboxylic function group. Means plus 1 oxidation number of aldehydic carbon gets converted into plus 3 oxidation number of carboxylic acid. So 2 moles of electrons are available per molecule of one molecule. We make available 2 moles of electrons. And the plus 1 silver, when it gets reduced, this get oxidized, something else should get reduced. So Ag plus ion, 2 moles of Ag plus will get converted into metallic silver. And then ammonia will get released. That is all what we have balanced. So these things should be known. And then the reaction, if you see it directly in the notes or textbook, you will not get confused. Things become not only easy, it become interesting.